Welcome to our video note session on Skill 7 from Unit 4. Of course, the guided note outline that you printed out for this includes all of Skills 7 through 9, but we are going to cover all of those skills over a course of 3 separate videos. And so this video is focused primarily on Skill 7, which is adding and subtracting radical expressions. Now, really all you need to know for adding and subtracting radical expressions is that you can only add or subtract if they are like terms. Okay, so this is really the only piece of information that is important. You can only add or subtract radical expressions that are like terms. So what does it mean for a radical expression to be a like term? It means it has to have the same index, which as a reminder is that little number that's written out in front of the radical that tells us what root we're looking for. So in order to be able to add radicals, they have to have the same index. The other thing is they have to have the same radicand. And as a reminder, the radicand is the amount that is in the radical. It's whatever quantity or expression is under the radical sign. So the index on the radical and whatever is under the radical sign have to be the same in order for those radicals to be like terms. Okay, this is what makes it a like term. So if that is the case, then you simply add or subtract them, and that's all you really need to do. Now, sometimes though, you will have to simplify the radicals first to get it to this point. For them to have the same radicand, basically, they'll need to be simplified. And then after you simplify, we will combine like terms. So let me show you what I mean. We'll start with number 1, which is an addition problem. All of the items here are being added. Now, the nice thing about number 1 is it doesn't require any simplification because the numbers under the radical are 5. And so 5 is a prime number, right? Its only factors are itself and 1. So therefore, it doesn't have a factor that's a perfect square that I could simplify. So these radicals are already in simplest form. So let's look at the things that are like terms. I've got 4 and 9, which are basically just integers. So those are like terms. I can add those together. And then I've got this expression with a square root, right? The index matches. And then this other expression that also is a square root has an index of 2. And the radicands of 5 and 5 match. So those are also like terms. So I will add the 4 and the 9 together to get 13. And then I can also add the 3 square root 5 plus the 2 square root 5 and get 5 square root 5. So what I did there, maybe I'll just kind of show you off to the side. What I did with the radicals is I added the numbers in front. This is similar to back in Algebra 1 when we added expressions like, here, let's look at a little memory bubble, a little trip down memory lane. When we added expressions like 3x plus 2x, we didn't add the x's, right? We just used the x to recognize that they were like terms, and then we added the numbers in front, the 3 and the 2. So it's the same idea here, except that the radical is acting like the way x acts when you're in an algebraic expression. It's just the like term. It's just telling us the name of the thing that we are adding together. So this is kind of saying we have 3 rad 5s, and then we're adding that with 2 more rad 5s. So all together, you just add the number in front. All together, I have 5 rad 5s. Okay, so that's kind of how we got this part. And for number 1, that's our final answer. So the theme is only add together the things that are alike. 4 and 9 could combine because they don't have a radical, they're just integers. And then 3 rad 5 and 2 rad 5 could also combine because though they did have a radical expression, that radical expression had the same index and the same radicand. So I could add the numbers that were in front to get 5 rad 5. Okay, so then looking at number 2, I can see a couple things. 1, they all have radical expressions, okay? And that not all of the radicals have the same index. So these are square roots here because there's no index written, so we know that those are square roots, whereas this right here is a fourth root. So right off the bat, I will not be able to combine the fourth root of 48 with these other two. Now, these square roots currently don't have matching radicands. They have 27 and 3. So this one will require some simplifying before I can combine like terms. So I'm going to start with the 27. I'm going to factor that into 9 and 3, and then the 9 can break into 3 and 3. And so what I notice is that I have a square root of 3. I have a perfect square of 9 that has a square root of 3. So I will bring out that 3 to multiply to the 4 that was already in front, right? So they connect through multiplication. And then this single factor of 3 stays under the radical sign. Now this middle expression was already in simplest form because 3 was the radicand and it doesn't have any other factors besides itself and 1. So it can't be further simplified. The 48 can be simplified, or at least I think it can, because I can divide it into other things. So maybe I'll break it into 8 and 6. And then 8 could break into 2 and 4. And 6 can break into 2 and 3. And then 4 can break into 2 and 2. So what I notice, so this can simplify because I notice it does have 4 factors of 2. So that makes a perfect fourth root, right? It's an indexed sized group, matches the index of 4. So I can take that out and get 2 in the front. Oh, sorry, that's a minus sign. That's a subtraction. So I subtract, the 2 comes out in front, and then this single factor of 3 would remain under that radical sign. Fourth root of 3, that remains under the radical sign. Now look at that. So the radicands all match. So this is kind of meant to deceive, right? All the radicands are 3. Every number under the radical is a 3. But they cannot all be combined because this radical is a fourth root versus a square root. A fourth root of 3 is a different quantity than a square root of 3. So they are not like terms. They cannot be combined. Okay, so we just kind of make a note of that. And then let's finish simplifying this one here because I need to multiply 4 and 3. So that's 12 times the square root of 3 plus 3 times the square root of 3 minus 2 times the fourth root of 3. I can combine the square roots of 3 because their indexes and their radicands match. And so when I do that, that becomes 15 times the square root of 3 because I add the numbers in front, right? 12 plus 3. And then that's going to subtract 2 times the fourth root of 3. And that's as simplified as the answer can get. So I want you to make a little note here that you cannot subtract these radicals because they have different indexes. All right, so you have to just keep it like this. This is already in simplest form. So we can only combine radicands with the same index and same radicand. Both have to be the same to combine. So moving on to number 3, I have 2 cube roots that, again, it looks like both of them need simplifying because currently the radicands don't match, so I cannot add them right now. But maybe we'll see if they can combine once they're simplified. So I'll start with the 32, which I can break into 8 and 4. The 8 I can break into 2 and 4, and the 4 can go into 2 and 2. And then this 4 can also go into 2 and 2. So 32 we've factored a lot lately, and basically it's just a product of 5 factors of 2. It's 2 to the 5th power. Now this is not a 5th root, this is a 3rd root. So I only need 3 2's to make a perfect 3rd root. So these other 2's will have to stay under the cube root sign because it wasn't enough to create another 3rd root. Now let's take a look at 108. So 108, I'm thinking maybe I'll just start dividing that by 2 since this is even, and that's 54. And then 54 can break into 2 and 27. And then 27 can break into 3 and 9, and 9 can break into 3 and 3. So yeah, I see a perfect third root right here with the 3 3s. And then I see again two factors of 2. That's not enough to make a third root. So those will have to stay under the cube root sign. Okay, so let's see what I've got here. For this first one, I can take out the 2 because that's a perfect third root. And then under the cube root sign, I have to multiply these other 2's back together, right? 2 times 2 is 4. So I've got a 4x under the cube root sign. And then that's being added to the cube root of 108x. But 108 is the factors of 2 times 2 times 3 times 3 times 3. So the 3 times 3 times 3 makes a perfect third root. I can take a 3 out. And then I have to multiply these 2's back together again, right? 2 times 2 is 4, and then there was an x in there as well. So now they are like terms, right? The index and the radicands match for both of these. So I go ahead and add the numbers on the outside. So this is saying, well, you have 2 cube roots of 4x, adding with 3 more cube roots of 4x, and so that all together would make 5 total cube roots of 4x. And so that would be my answer there with that one. And then lastly, we've got example 4 with square roots again that look like they already match, right? I've got a square root of 7bc and then another square root of 7bc. So I can go ahead and combine those as long as these are also like terms, right? There's an a out in front. And so since those are also the same, right, we've got to make sure our variables and our indexes and our radicands all match which they do. So I can go ahead and add the 14 together with the 5 and get 19a times the square root of 7bc. And that's pretty much it for that one because it was already in simplest form and everything was actually like terms. So we just add the numbers in front. So that will conclude this video on just Skill 7.